All right, so I suppose I should probably review um, a couple of things. So, in one thing I want you guys to know is that we are going to got to get Boilermakers in there. Um, we're going to do our solutions are going to be a set of numbers. So, if I say x is greater than 3 or x is less than -2. If I go to graph this on the number line, I have two values of interest. Something happens here at -2, and then something happens over here at 3. And since I don't have an equal sign, I'm going to put an open circle at 3. That says x is greater than. So I'm thinking of any value greater than 3. So I'm going to go this way, right? 4 is greater than 3. 5 is greater than 3. Open circle going to the right. And I suppose I could do the same thing here. This is saying that x can also be less than 2. So I'm not going to include 2, but I'm going to include any value less than 2. Since I don't have an equal sign, I'm just going to do an open circle. So now this whole thing is what we call a solution set. So with our absolute value things, we're going to solve. And when we get to the inequalities, we're going to have what we call a solution set. There's more than one value that will make the equation true. All right. Now, what you may not remember is that this is what we call a union. Okay, this is called a union. What's funny is, for some reason, that looks weird. No, I spelled it right. Just looks weird. Now, sometimes we're going to have something that looks like this. Now, this one, when we go to graph it, we still have the same two numbers of interest. We have -2 and 3. It's changed a little bit. What I should know is that I could break this up into -2 is less than or equal to x, and then I could say x is less than 3. Now, the other part about this is that this can be written as x is greater than or equal to -2. Notice that here the inequality symbol is pointing towards the -2. If I put x on the other side and I point it towards the -2, I'll get an inequality that looks like this. So now if I go to graph this, because -2 has an equal sign, right? X is greater than or equal to -2, I'm going to put a closed circle. That means I'm telling the reader this thing includes -2. And it's any value greater than -2. So that means I go to the right. Now for over here, I'm saying x is less than 3, no equal sign, open circle. And any value less than 3 goes this way. So when I go to graph this one, I have a closed circle here at 2, and it goes all the way to 3, open circle. I'm sorry, -2. So from -2 to +3. Now this is called an intersection. So a union can be written a couple of ways. If I wanted to write this union, I would say my lower boundary is from -infinity to 2, And then my upper boundary, well, I shouldn't say upper boundary. I should say upper solution set is one way to word it, goes from positive 3 all the way to positive infinity. But because it's a union, I use a big U that stands for union. Okay? So at some point in time when we solve these inequality symbols, we could write it this way. Now for this one, I've got a boundary. You could write this a couple of ways. One way is just put the lower boundary -2, comma 3. Oops, I made a mistake. Do you see what my mistake is? I've got to put the bracket in there. Okay? Or if I were to write this separately, I could say, well, actually, that's how I have to do it. An intersection is an interesting thing. I could say, the problem is that with the set node, you could write it this way. You could say x is greater than -2, and then you could say union. So intersection is the upside down U. And then x is less than 3. You could write it that way. Technically, that's not right. Really, because we wrote it as an intersection, we're just going to leave it this way. Okay? There's lots of ways you could write it, but this means intersection. You'll never do this in high school. Well, maybe if you take upper level math, but most of the time you'll never do this sort of thing in high school. And even that is not formally correct. But I just want you to know that when you come to a union, and by the way, a union, when you graph it on a number line, always goes out like this. Whoops, I got to get in this camera. It always goes out like this. That's a union. An intersection, they overlap, right? Intersection, they overlap. Union goes this way when you graph it on a number line. Any questions on that? Okay. Good.